Okay, the extended basic functions. And I'll kind of write that. We just draw a smooth curve through the graphs, and we get a good approximation of each of the extended basic functions. So, yeah, I'll stick with this color. Okay, so we start here, come down to here, we come down to here, we hit the origin, come up here, and we come up here, and there's our extended basic function. Now, the extended basic function stops at 2 and starts at -2. Okay, it's defined only in the interval from -2 to 2. And it's on the closed interval, so you include this point and this point, but that's pretty much implicit. Okay, basic exponential function. Nice smooth curve through those points. The extended exponential function. Extended basic exponential function. Okay, the extended basic reciprocal function. Now we have to be a little careful here. You know, as we saw, when x equals 0, you don't have a point. Okay? When people draw this graph, they want to connect this point to this point, which is a natural enough thing to do, unless you stop and think about the fact that there is no point on the y-axis. So there's no point in trying to connect this and this. There's nothing on the y-axis because there's no value, because the function is not defined when x equals 0. So when we draw this, we do this, and maybe we extend the graph a little bit. And we stop at 2, and we start at -2, but there are points, there are x values that get closer and closer to 0. And we know from division that if we keep dividing by smaller and smaller numbers, we're going to get bigger and bigger results, because it takes more of a small number to add up to 1. Okay? So as we get closer and closer to the x equals 0, these values are going to get bigger and bigger. And there's no limit to how close we can get to 0, so there's no limit to how big the y values can be. And if the y values can be as big as we wish, that means that this graph, that this curve is going to continue on forever, getting closer and closer to the y-axis, but it's never going to get there, because as we approach 0, we never get to it. We can't get to it for this function because it's not defined when x equals 0. Okay, so similarly on this side, that gives us what's called a vertical asymptote at the y-axis, at x equals 0. And that's a term that everybody should be familiar with from prerequisite courses. So I'm not going to say too much more about that, but I will note, pick a good color to note this in. And this is good enough to write with a little note of red. It's an asymptote at the y-axis. And just remember that red doesn't necessarily show up real well, but there it is. And the asymptote is on the left side of the axis here, on the right side of the axis here. And it should be obvious why, because you've got negative values over here, excuse me, positive values over there. Okay, now the basic cubing function, well, we connect these points with a smooth curve. The curve has to almost flatten out there at the origin, because it's so close to the x-axis all the way out to 1/2. Okay, I kind of missed the 1, 1 point. I thought I had it. No, I kind of blew it. But anyhow, do that and do a better job than I did. There it is. Nothing particularly fancy about it. If you look at this part of it, this part of the curve, it looks a lot like this. How is this different than this? Well, it's because of that 1/8 there and that 8 up here. It goes up higher, comes down lower as it goes through 1 than this one. So it gets flatter as it approaches 0. And then on the other side of the axis, well, you've got this symmetry thing going on here. It's just like this part of the curve, except you flip it. And we'll talk about symmetries and so forth, so I don't want to get too far into it right now. But there we have it. Okay? Now the basic reciprocal function, well, the reciprocal square function, that's a whole lot like this one, except it goes up a lot faster. If I just connect these 3 points, I see it comes down here. Yeah, I'm kind of missing it. Okay? And then same thing here, just for these 3 points. And we see that what's going to happen on this side is, again, we're going to have an asymptote at the y-axis, because, of course, when x is 0, we have the undefined. And as we approach 0, x squared approaches 0 faster than x does. And this thing's going to blow up. It's going to get much steeper, much faster than this one. It's going to have an asymptote here. We can kind of indicate that with an arrow. I did draw the arrow over there because I had some labeling I could have. And there we have it. Again, we have asymptotes. We have an asymptote. Again, because of the fact that when you divide 1 by a tiny number, you get a big result. And the numbers get unrestrictedly tiny as we approach x equals 0. Okay, well there you have it. Those are the extended basic functions.